Hey, Jody here with weldingtipsandtricks.com. Today we're going to work through a handful of TIG welding repairs on some carbon steel, stainless steel, and aluminum. These are just really common repairs that you would see from a machine shop. Things like a misdrilled hole that needs to be filled in so that it can be relocated, or there's not supposed to be a hole there. A chamfer on the wrong side, it's not supposed to be there, you need to build it back up. Or just a place where a tool crashed, or a place that the mill got crazy and went a little too deep where it needs to be built back up. Sometimes parts can be salvaged like that. If a welder can add just the right amount of metal in the right place without distorting the part, then everybody's happy. Other times, part needs to be remade, but that's the machinist's job to make that decision. If he needs a part saved and you can save it, you can pick up a little work on the side. So this is a good example of a part here. It's a dead part. It looks like it was probably just used for a setup, but it's a good example of a lot of machining has been done already, some mill work and some large chamfers, some threaded holes, and then on the back side here we got what appears to be where the tool changer just didn't pick up something right and crashed into it. Now my main concern there would be that there's bits of carbide bit in there that just broke off from the end mill or whatever. So I'm doing a little grinding here, get them mostly out of there and check sparks, and it looks like it was just big burrs that got dug out of just mild steel. But we'll give it a little quick wipe with acetone and then that's ready for welding. Now I'm doing all the welding today with this machine here. It's an Everlast powertig 210 EXT. I've done a lot of machine shop repairs over the years with an inverter of about this size, a 200 amp inverter. So we'll go through the settings here real quick, and basic settings. I'm not using anything here fancy. I'm just putting it on DC, using the foot pedal. I want to set the post flow to a little higher than just enough to keep the electrode silver. So I'll go on up to 10 seconds or 0.2 second pre-flow. I want to have the start amps high enough to get a good crisp start because it's really thick metal. So by setting the amperage at about 15, I'll make sure and get a really crisp start with a good sharp 3/32 electrode. And I'm going to bump the amperage all the way up to 160 here. I know I won't need quite that much, but if I do at start, I'll have it, and I'll just work the foot pedal from there. Also, I want to do a quick check on my purge. I hit the gas purge button there. That lets me check the purge without having to worry about the post-flow timer running out, and I'll set it at 20. I'm going to be using a number 8 gas lens cup here today, and that's why I'm setting the gas flow at 20. And I am using 1/16 diameter, that's 1.6 millimeter diameter ER70S6 wire. It looks like stainless wire, there's no copper coating on it, but it's not. It's ER70S6. It's just not coated with copper. No reason for me choosing that other than it was handy. I would just as readily pick up a ER70S2 wire for this repair. But I'm starting in the middle. I'm adding quite a little bit of height to it, and then I'm just going to work my way out. And this is kind of a little trick I learned from a guy at Pratt & Whitney about kind of how to build up a round area without having too much shrinkage stress. Start in the middle and then kind of like build beads around it so that the beads have something to hug onto as they shrink. Helps a little bit, not a huge difference, but I'm doing it this way just for kicks, and then I'll work my way all the way out to the very edge and let it cool before I put that last bead on there. The gas lens helps each bead to stay shiny and keeps the oxidation down so that the top beads that you put over top of those flow over nice and smoothly. So it's still nice and shiny, but I got one more bead to put around the outside. I'll give it a quick wire brushing and I'll let it cool for about a minute or so. This is a good half-inch thick piece of metal, so heat's not building up very quickly. One more pass around the outside, we'll take care of it. Trying to keep the tip of that rod shielded with the argon. A number 8 gas lens cup is a half-inch. Gas lens and all other cups are numbered by the 1/16 of an inch. At least in the USA they are. So I'm trying to keep the tip of that rod shielded, and it's not too difficult to do because with that large shielding area from the number 8 gas lens cup gives me a bigger gas envelope. Then I'm going to work my way inward here and just do a little blending with the arc to make it easier to mill or grind or whatever for whoever has to do that. Make sure I don't have any low places. Just kind of blends the high places in with the low places. Alright, so that little repair is done, and the 8 gas lens did a great job. Alright, well that was a really simple repair, just filling in a little miscut, and nothing to it really. So I've got a couple more little carbon steel repairs here, and we'll pan to those and we'll get right on to them. I'll just describe them when we look at them up close. This is just regular old cold rolled steel here as well, 1010 to 1020 carbon steel. But it's got a milled area there that's not supposed to be there. And again, this is a piece of scrap, but it's a good example. I've seen this many times, things like this where, you know, the CNC operator has to pull the part out of the machine for something, or hit the kill button and then he doesn't hit the sequence button right. Something happens where it doesn't pick up the last step like it's supposed to, and then you got a cut area that you're not supposed to have. So the idea here is to kind of build some boundaries around this thing so that the edges stay built up to where they could mill off. So I'm kind of building 4-sided little dams here. I put a bead on each end, and then I'm now going to run 2 more beads to make boundaries on the other edges to make sure they're high enough to give me something to weld to. So I'm pushing a little filler wire in there each time here as I weld, because it is a build-up job, so I don't want to just dab the minimum amount. I want to feed a little rod in there, make sure I got enough bead height that it doesn't go to the mill and then come back with another low place. That's the worst thing in the world. When you build something up with weld, you send it back to the machinist, and then there's still not enough, and now it's got to be re-welded. So rule of thumb on build-up jobs, when you think you have enough, put a little bit more. Four sides built up here and kind of like some boundaries to go by. Now I'm just going to point the electrode in this direction. Now I can go fairly hot to make sure that I don't have any voids, and I'm going to run more or less one continuous bead, just changing directions and then overlapping the previous run across by half, just kind of keeping an eye on everything to try to make sure I push enough filler wire in there to make it high enough that it would machine off without any low places. Just more of the same, and then I'll stop about 3/4 of the way through and then come back from the other direction, and then it looks something like that. Here's another example of a job you might have to do for a machine shop, and that is weld down inside a hole like this. Maybe that step got machined down, you know, 50, 100, 150 thousandths further than it should be. Now this is a simple part. It probably would just be remade again. Really all there is to it is a piece of bar stock with a couple of holes that have been drilled with a step in them. But just for the sake of example, I'm going to extend the electrode out really far with this number 8 gas lens cup, and we're going to weld down inside there after having cleaned it out with a carbide burr. I've also got a piece of aluminum backing this up to kind of trap the argon. That really helps a whole lot. So even though I've got the electrode extended almost 3/4 of an inch, it welds pretty clean down in there. Alright, now for the aluminum. A chamfer that's not supposed to be there is a very common thing, and that's something that can easily be repaired and machined back off. In this case, the aluminum is relatively clean, so all I'm doing is an acetone wipe prior to welding. Now we're going to swap over to alternating current advanced square wave here, using a foot pedal, no pulse or anything. To set the AC balance to 40% cleaning. That's the equivalent of 60% EN. That's going to be enough cleaning to give me a nice clean bead, and that's really all I want for one bead or 2 beads down that chamfer. I'm not concerned about focusing the arc. I'm not concerned about deep penetration. I just want a clean bead that will machine off without any pits or pinholes in it. So we'll set the post flow now to just enough to keep that electrode silver, which, you know, somewhere around 9 seconds should do that. You don't need any more than that for aluminum. And I'll still keep the 0.2 seconds pre-flow. Start amps I'm going to set up fairly high, so I'll get a nice crisp start. I'll have a blunt tapered electrode. I don't want any stuttering on the start, and I'm going to crank it up to 200 amps and just work it with the foot pedal. And after the fact, I did not need anywhere close to 200 amps. Didn't know that going in though, because this is a 1/2 inch chunk of metal that's at room temperature. So I'm running a bead right down that chamfer, trying to wrap the edges, which is why I didn't really want a narrow bead with a focused arc like you might have with, 100 or 120 hertz. So this is set at 77 hertz. And I'm just going to turn around and weld backwards and go in the opposite direction. Welding backwards like this oftentimes puts a higher crown on the weld, which is really kind of what I want. Here's another view of it. I want a higher crown because it's got to machine off, theoretically anyway, to a corner. So if I'm building up a chamfered area like that, it makes sense to make a higher crowned bead like that. So that's two runs there without stopping, starting on the corner, welding inboard, and then turning around and welding the other direction. And that looks like that would clean up by machining pretty well. And then I also just messed around going backwards twice, running 2 passes, welding like this, feeding the rod from the back side. One thing you do have to do is you have to do a little backwards motion to kind of remelt any little trailers from pulling the rod in and out. But after doing that, making 2 passes, it still made for a pretty decent fix that would machine off just fine. Now for the stainless job. This is just a little stainless bracket that I pulled out of a scrap bucket, and let's just pretend that middle hole is not supposed to be there, that the slots are and the middle hole is not. That's a very common thing, to have to fill a hole. I like to use aluminum backing, so I save all the chunks of aluminum like this I can get my hands on. Ideally, use argon backing for something like this, but it's really not necessary. That aluminum works just about as well. So all I'm going to do now is just swap it over to DC and then bump the amperage down just a little bit and still control it with the foot pedal and weld. With that aluminum backing on the backside, what it will do is it will trap argon. It'll trap the argon shielding gas and won't let it flow through and create any kind of Venturi effect or anything like that. And it just helps everything shield better. It also provides a place if you go overboard and really use a lot of heat, the molten metal can only go so far, so it's not going to like droop through like a big mound and where you have to grind it off afterwards. So I could really weld a lot hotter than I am here, but I'm just trying to use minimal heat because this is stainless steel, so that's a good practice on stainless, not to use any more heat than what's necessary. And I'll taper off now, let it cool for about a minute before I then come back and then touch it up, add a little bit to where it could be either blended off or machined off. I don't want to do it all in one run though, just a little bit, camping out too long on a piece of stainless to do that all in one run, the whole fill and build up here. So I'm just running once around it, add a little dab of rod coming across the middle, taper off to avoid a crater hole, and then that side is done. It's 1/4 inch thick metal. That's about I guess 6 point something millimeters thick for everybody outside the US. Give it a little wire brushing here, kind of inspect it, make sure it's going to be okay, and we'll let it cool for just a moment, flip it over, keep it on that aluminum block to pull out the heat, and then touch up the other side. Now you can see a little area here that's a little deeper than others. I'll focus on that area first and kind of pump some amperage in there. Looking at it after the fact, it probably would have done better if I'd have gone all the way around it, rolling metal around the edges and then filled up the middle. That's just not the way I did it. Don't know why. So I'll light up on it now, and I'll melt all that stuff that I didn't get the first time around, and then I'll start adding rod, and then we'll build it up a little bit to where it can be blended off flush, and then we'll call it done. Alright, a word about gas lens setups. Now this is sort of a commercial, so if you got a problem with that, you might want to bail out now, but I think that there is some good info to be had in the rest of the video as well. Standard style cups using certain stickout lengths just don't work as well as gas lenses. I've set up one with a 7/16 stick out here with 20 CFH, a number 6 cup, 45 amps on a stainless steel lap joint. And you can see it's gray, it's squirrely, it's not flowing well. I'm not doing this on purpose, I promise. It just, at a certain stick out distance, stainless just doesn't do well if it doesn't have good gas coverage. And it looks like 7/16 is just beyond the coverage distance for this style cup. Now, doing the same setup with a gas lens, and this is a Stubby gas lens kit here on a large torch, but I've even set it out a little bit further with a number 6 gas lens cup. Same size cup, same flow, 20 CFH. Even longer stick out. I'm going to call it 7/16, but it's longer. Same amperage, same everything, and there is a huge difference. Stainless steel really kind of brings it out more so than a lot of things. But, you know, in addition to using a good technique where you get in, get your puddle started, get moving, don't let the heat build up, a gas lens is your best friend for doing stainless steel sheet metal. And in the exercises I did in the video, all those repairs for machine shops, stainless steel and whatnot, where I'm welding bead on top of bead, it makes it go a lot better. You'd be hard pressed to find a welder that bought a gas lens setup and regretted it and thought, man, I wish I'd never fooled with this gas lens. So anyway, I do sell them both now. I sell a Stubby kit that's for large style torches like the 17 and 26. So not only does it shrink the size of your torch a little bit, but it gives you a lot better coverage. Now I've got the gas lens kits that if you already have a small style torch like a 9 or a 20, this is what you need. The 6, 7, and 8 cup. A long end cap along with a button and a mid-size, one size each of electrodes along with the 1/16, 3/32, and 1/8 diameter setups. You can stick out your electrode a little bit farther, get a little bit better coverage so that when you're doing bead on top of bead on top of bead build up like this, it comes out a lot better. Alright, thanks for watching. Appreciate your time. We'll see you next week.